On March 17, 2025, humanity made history. For the first time ever, we saw what had never been recorded: the sun's south pole. No simulation, no artist's rendering, an actual photograph of one of the most mysterious and dangerous regions in our entire solar system. Captured by ESA's solar orbiter, the image revealed details even Earth's largest telescopes could not show. And a single question echoed through every research institute: why did it take us so long to see this? What lies there that could silently influence all life on our planet? This region is not just a geographic pole. It is a dynamic engine of the sun's magnetic cycle. Every 11 years, an invisible force flips the sun's polarity, free-shaping the heliosphere, the magnetic bubble that shields our solar system. And when that flip occurs, Earth feels it. In solar storms, rare auroras, satellite glitches, and communication blackouts. Astronomers often joke that it's easier to study the center of the galaxy than to glimpse the top of our own sun. Conventional telescopes stare from the equatorial plane. The poles, tilted and blasted by radiation, have stayed hidden. Until now. Thanks to solar probes like Solar Orbiter, we have finally opened a window into the backstage of the star that makes life possible. And that window could close at any moment. These first images mark the dawn of a new era in heliophysics. Solar Cycle 25 is already underway, and the poles hold the key to its impact. What we're witnessing is the start of changes that may affect not only Earth, but the entire space environment around us. Solar flares may intensify, magnetic storms may grow, and for the first time, we can try to forecast what's coming with real data. This is our first look into the sun's magnetic heart, and what it reveals could rewrite the future of our relationship with space. Behind the golden light that warms our mornings lies a heart in constant turmoil. The sun is not a perfect lamp, it's a boiling ocean of plasma, where magnetic fields twist like the currents of an invisible hurricane. Across this blazing surface, small dark spots mark regions of magnetic tension. But it's in the poles, where no human eye had ever reached, that the sun's true engine spins. Imagine a compass so large, it influences all of existence. Every 11 years, the solar needle flips. North becomes south, south becomes north. And in this reversal, the sun releases bursts of energy that can envelop the entire solar system. This is where the story stops being cosmic and becomes personal. When the sun's magnetic field shifts, it sends waves of charged particles traveling at millions of kilometers per hour. If they reach Earth, they can set the skies on fire with auroras, or take down satellites, shut off power grids, and disorient planes flying near the poles. Think about your GPS, your internet, even your phone. They all depend on a delicate balance between our magnetic shield and the sun's ever-changing mood. That's why seeing the pole for the first time isn't just academic curiosity. It's our first real chance to forecast the next solar storm before it strikes. And now, science is finally staring directly at the trigger. What we discover may shape how we protect our civilization, or survive the next eruption that could, without warning, throw us into the dark. When it comes to exploring the sun, getting closer isn't always the answer. Sometimes, we must observe it from afar, through an unlikely angle, with eyes designed to see what has never been seen before. That's exactly what the Solar Orbiter mission achieved. On March 17, 2024, it captured the first clear image of the sun's south pole, a region that had remained invisible to human science. The success now making headlines began years ago, in 2020, when ESA launched the spacecraft in collaboration with NASA. Since then, its trajectory has been meticulously designed to escape the ecliptic plane, using Venus's gravity as a slingshot and shielding its instruments with cutting-edge solar armor. To understand the magnitude of this achievement, we must also look at its older sibling, the Parker Solar Probe. Launched in August 2018, while Parker dives into the sun's corona, facing brutal heat, it has become the fastest object ever made by humanity. In contrast, the solar orbiter keeps a strategic distance. Together, they represent two sides of the same mission: to decode the sun from the inside out, and now, from top to bottom. Parker brings back data from the heart of fire. The orbiter studies polar patterns, trying to reveal the magnetic cycles that shape Earth's space weather. The image of the sun's south pole, revealed in March 2024, was taken from 44 million kilometers away. Yet it unveiled brand new data on magnetic jets, rotational patterns, and previously unknown solar structures. Scientists say it's like discovering a missing piece of the solar cycle puzzle. And it matters more than we think, because by understanding the poles, we can better predict solar storms, the same ones that disrupt satellites, power grids, and even airline flights. Observing the sun's south pole is, in practice, a glimpse into Earth's future. At the heart of it all lies an image that is not only beautiful, but vital. An image that unites 2 space missions, 4 science agencies, and decades of planning. A single frame that proves how, even after millennia of worshiping the sun, we still know so little about it. And that little is finally coming to light. The first image of the sun's south pole brought more than beauty and symbolism. It brought questions, and it revealed things that began to shake what we thought we knew about solar physics. What scientists found was not a calm or predictable magnetic field, but a dancing chaos. Twisted lines of force, woven into patterns like living webs, something never seen in other regions of the star. Sunspots emerged in unexpected areas, ejecting plasma in irregular bursts. It was like staring into the heart of the unpredictable, with the camera aimed at what was once only a guess. The data is still being processed. ESA, NASA, and independent astronomers around the globe are releasing their first reports, and all of them say the same thing, with a gleam in their eyes. We're only scratching the surface of the unknown. They know these magnetic patterns could be the key to understanding the sun's activity cycles that affect everything from Earth's power grids to astronaut health in deep space. That's why every pixel of that image is valuable. Every distorted line is a clue, a piece of a puzzle that might prevent disasters or protect entire civilizations. One of the greatest hopes now is to better understand magnetic reconnection, an invisible dance of energy fields that, when they snap and cross, release absurd amounts of power. That's what can trigger massive solar storms, and the sun's poles seem to be the perfect stage for this dangerous event. By studying those twisted lines, scientists hope to forecast events like the Quebec blackout of 1989 or the GPS disruptions we already face. But the truth is, we still don't know enough. The South Pole may be the key. What we've learned is huge, but what's left to learn could change everything. The sun has revealed its South Pole, but not all of its secrets. We still stand before an invisible dance, forces we barely understand, yet they could change the course of our civilization. And the question now is, what if the next solar storm is already on its way? Are we truly prepared? Scientists are still analyzing every detail, every magnetic pattern, every distortion, every pulse of energy, because the answers might lie inside this unprecedented image. And what it reveals may define our future or expose our vulnerability. And the most astonishing part? This new image of the sun is just the beginning. We're still only scratching the surface. Subscribe to CuriousVerse, like, share, and hit the bell icon, because what's coming might be greater than we can imagine. And remember, the next eruption will not come with a warning,